Now we're going to cover an example of linear programming. Linear programming is a method for finding the maximum or minimum value that satisfies certain conditions. The constraint is an inequality or a condition. The feasible region is the solution to a set of constraints. The objective function, the best combination of values in order to maximize or minimize a function. The vertex principle. If an objective function has a maximum or minimum value, it must occur at one or more of the vertices of the feasible region. The steps. Number 1, graph the constraints creating the feasible region. Number 2, find the coordinates of each vertex or corner. Number 3, maximize. Evaluate each vertex to find the biggest number. Now, once we go through the example, this will totally make sense. Our example is Yum's Bakery. They bake 2 breads, bread A and B. One batch of A uses 5 pounds of oats and 3 pounds of flour. Now, as you're going through this, I suggest highlighting or underlining the important aspects. A uses 5 pounds of oats and 3 pounds of flour. Meanwhile, B uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour. Write the constraints for the problem and graph the feasible region. First, we need to create inequalities that describe the oats and the flour. Bread A had 5 pounds of oats, so we'll say 5A plus bread B used 2 pounds of oats, 2B, and we know the company has 180 pounds of oats. Well, we can use all 180 or we can use less than that, but we cannot use more than 180 pounds. So less than or equal to the 180. Now, it's up to you to determine which is X and Y when we graph these. Personally, I'm going to use the A as my X and I'm going to use the B as my Y. Well, if I need to graph this, I need it in slope-intercept form. That means y equals mx plus b. So I need to solve for the y. In order to do that, I need to move the 5a to the other side. That gives me 2b is less than or equal to negative 5a plus 180. Now I need to get the b by itself by dividing by 2. B is less than or equal to negative 5 halves plus 90. So my slope will be negative 5 over 2, and my y-intercept will be 90. Next, we'll do the same exact thing with the flour. Bread A uses 3 pounds of flour, so I'm going to say 3A plus, and bread B uses 3 pounds of flour. 3B. I have a total of 185 pounds of flour available, so I can use equal to or less than, but I cannot use more, so I say less than or equal to 135. Now we're going to go through the same steps. I'm going to solve for B by subtracting the 3A and then dividing by 3. That gives me B is less than or equal to negative A plus 45. My slope is equal to negative 1 over 1, and my y-intercept is equal to 45. Now I need to set up my graph. I'm going to count by 10, 10, 20, now I'm going to label my graph. We said that bread A are the X values and bread B are the Y values. So down at the bottom, I'm just going to label it bread A, and on the side, I'm going to label it bread B. Now that I have these labeled, I simply draw the graphs. For the oats, I know that my y-intercept was 90. Well, 90 is a little bit off my graph, so I'm going to have to scroll up. my y-intercept was 90, and my slope was negative 5 over 2. That means if I go down 5, I'm going to have to move over 2. If I go down another 5, I'm going to have to move over another 2. And we're going to keep doing that all the way down until we get to the bottom. When I get to the bottom, I'll be at 36, 0, and we draw our line. Now you notice I'm only working in quadrant 1, and I don't have arrowheads. This is because I cannot have a negative amount of flour or wheat or bread for that matter. I'm only dealing with the positive numbers. Now we do the same thing for flour. The y-intercept for flour was at 45, and the slope for flour was down 1 over 1. Down 1 over 1. That's going to go all the way down and end at 45, 0. Then we draw a line and we label our points. I've already labeled the x-intercept for both of them. The y-intercept was 0,45. But the most important point are where the two cross, right here. So if we follow our graph, we're roughly at x value of 30, y value somewhere halfway between 10 and 20, which is about 15. So I will call that 30, 15. If we go back up to the steps, it says to graph the constraints, creating the feasible region. So we graph the constraints. Our feasible region, remember these are inequalities, both facing less than. That means the feasible region will be the point of overlap, and these two lines will overlap with right in here. So we fulfilled step number 1. Step number 2 is to find the coordinate of each vertex, which we did. We have 0, 45, 30, 15, 36, 0, 45, 0 is outside our parameters, so we don't need the 45, 0. The three that we worry about are 0, 45, 30, 15, 36, 0, and really 0, 0 is an option, but if you never make any bread, you're not going to make any money. Now, step 3. Step 3 is to maximize. Evaluate each vertex to find the biggest number. So what we're going to do is plug those vertices into an equation, but we still have to make the equation. That's where the second half of the problem comes in. Yum's Bakery wants to maximize its profit from bread sales. One batch of A yields $40. One batch of B yields a profit of $30. If we highlight the important information, we know that A yields 40 and we know that B yields 30. So we write an equation. P for profit is equal to 40A plus 30B. We want the biggest number. So what we do is plug in our 3 separate vertices. We'll start with 0, 45, which means we made 0 of bread A and 45 loaves of bread B. So the profit would be 40. We made 0 of bread A plus 45 of bread B. That gives us a total of 1,350. Next, we'll try our other vertex, 36, 0. That means we made 36 loaves of bread A and 0 of bread B. We plug that in. Profit is equal to $40 times the 36 loaves of bread A plus $30 times the 0 loaves of bread B. 40 times 36 comes out to $1,440. So we're better off to make all bread A and 0 bread B. We make more money. Now, we have one more vertex to try. We have the 30, 15 that we still need to try. Profit equals $40 times 30 of bread A plus $30 times 15 of bread B. 40 times 30 is 1,200 plus 30 times 15 is 1,450, which gives me a total of 1,650. That by far is the largest number. So our answer would be in words, and we would say Yum's Bakery should bake 30 loaves of bread A and 15 loaves of bread B in order to maximize profits at $1,650.